fun. Okay, we're going to do number 3, number 17. Is that it? That's all there.
Number 9.
And number 9?
Oh wait, no, not number 9. Number 15.
Number 15. Okay, number 44, the answer is down here. Okay, 3, 15, 17. So we're number 3.
Can you also do
Oh, I need the equations more than I need the... Okay, so number 3 is f of x plus g of x. F of x plus g of x, number 3. So I have negative 3 x to the 1/3 plus 4 x to the 1/2 plus 5 x to the 1/3 plus 4 x to the 1/2. We combine like terms. So this gives us 2 x to the 1/3 plus 8 x to the 1/2. Okay, is that the right answer? Okay, the harder part with this one is the stating the domain. Now, does x to the 1/3 is same as cube root of x? Is there any number that you cannot put in cube root, third root of x?
No.
Can you put in negative 8? What would that give you? Negative 2, which is fine. Can you put in 0? Yes, that gives you 0. Can you put in positive 8? Yes, because that would give you 2. Okay? However, with this x to the 1/2, which is square root of x, can you put in 4? Can you put in 0? Can you put in negative 4?
No.
No. Therefore, the domain is set of x, where x has to be greater than or equal to 0. That's the domain. Questions? Okay. Now, just to make sure we're on the same page. Okay. I'll give you a different problem that is a little bit more interesting, just to make sure we're all on the same page. Let's say g of x is actually a minus 4x to the 1/2, which means this is actually a minus x to the 1/2, which means instead of 8 here we have a 0, which means instead of 2x to the 1/3 plus 8x to the half, this is just 0. Okay? How does that change the domain? It doesn't. Even though they cancel out, in the process of your simplifying, plugging in a negative 4, in this case, will still break actually both of the factories. Does that make sense? So if this is a factory like we talked about before, this is a factory that built glass, and this is a factory that built the case of the iPhone, and your h of x, which is your Apple company, put the two products together, at the end you end up with an iPhone. However, you still can put things in that break the glass or break the case. It doesn't matter at the end, those two products cancel each other out. Your two factors will still break, and therefore your domain actually depends on your x value throughout the process. Does that make sense? So you always look at, right when you plug it in, does either of the factors break? If they do, your domain is still limited to x greater than or equal to 0. Okay? Thumbs up, sideways, down. Okay. Let's have closure right now, so let's make sure everyone has a thumb up. If you have your thumb sideways, which part did I lose you? Do you understand it before I take it away? Okay. It's when I take it away that it becomes confusing. Right? Okay, good. So you get that when x to the 1/2 requires input to be 0 or positive. That part you get. I see all the nodding heads. The question is, once I simplify and it's gone, why is it still a domain issue? Right? Now, the way you think about it, let me see if, again, best teaching strategy, repeat it 3 times. Hopefully you understand. I just heard from Mrs. Alda this morning. We're having a planning meeting for youth group. And she said research has shown that you actually need to share the gospel 7 times to the same person for them to actually understand what the gospel says. So sometimes you just have to keep repeating it. But let me try to say it. Hopefully, maybe I'll point out some of the details that wasn't clear before. H of x is a new composite function we're trying to create. And h of x, the goal is that h of x will have the effect of f and g together. That's our goal of h. However, h is really defined by this. H is not defined by that. This is a simplified version of h. H is actually this. That make sense so far? Okay. Let's say you have a factory H that take acid. What's the opposite of acid? Base. So there's a liquid that's acid that they make, and a liquid that's basic. Right? That's how you use it as an adjective. That's basic, and they mix it together to make purified water. Does that make sense? So in the effect, in the process, acid and base are canceled out. It doesn't exist anymore. Okay? It still makes the factory potentially really dangerous in the process. Does that make sense? So you can say that h of x, the output, doesn't have any acid or basic chemical, whatever. So you can say that the output of H is water, which means anything can go, but it's really defined by a combination of acid and basic that in the process could hurt things or break things. Does that make sense? So it doesn't matter what you end up with at the end, might not have any limitation to the domain, but the process of making the acid and the process of making the basic water still has its own limitations. And you have to respect that even when h of x is simplified to something that doesn't have that limitation. Give me again, thumbs up, sideways, down. Okay, good. Let me give you as simple as it gets, make sure we can all get this one. Let's say we have f of x is equal to, perfect one. And g of x is also equal to 1 over x. Okay? What is h of x if h of x is g of f of x? This one's so good that it should be on the test. I'm giving it to you now. So everyone do this one. Write down your domain. Let's see if you can get the right answer. So we're not multiplying. We're actually plugging it in. Okay. This is not g of x times f of x. G of f of x. Okay. So we're not multiplying here, we're actually plugging in f of x into g of x. How do we multiply? How do we multiply? We're not doing that. We're plugging in h of x to g of x. Now that's multiplying. You're actually plugging in. Okay? So this is actually this. So we take g of x, which is 1 over x, but instead of x, which is the input, you input f of x. Okay, so this is 1 over x. That simplifies to what? X, okay? This is actually a great introduction to 3.4, which we're going to do today. Because these two functions are inverse of each other. They cancel each other out. Okay? 1 over x and 1 over x, 1 over x is inverse of itself. Every time you apply it, you cancel out the one before it. That's what inverse is. And this is what we're going to talk about in 3.4. Okay? So basically, when you do g of f of x, when they're both 1 over x, the result is nothing. It doesn't do anything. H of x is simply x. So when I plug in 10, what do I get? 10, right? This, again, is almost like saying this, y equals x. When I plug in 10, you give me 10. When I plug in 0, it gives me 0. When I give you -4, it gives you -4. That's what's true about this. What about h of x? When I give you 10 is 10. When I give you -4 is -4. When I give you 0 is. When I give you 0 is. When I give you 0 is undefined. Okay? Because it breaks both of these. And actually, it breaks f of x first. Right? Again, h of x, even though at the end the product, the output of the function is just nothing. It doesn't do anything to the input. But to actually get here, you're actually doing something to it and then doing something to it again. Any questions? Thumbs up, you would have it down, sideways, still a little not sure. Still some sideways. Is there another analogy I can give you? Okay, think of it this way. Jason's job is to take a piece of scissors and cut the paper in half. Okay? And Shoko's job is to take a tape and then tape it back together. Perfect. At the end, you have what? A sheet of paper. Just the way you started. Okay? Now, so I can say that if I have a piece of paper, I put it here, nothing happens. It's almost like they didn't exist. Okay? However, if I have a metal sheet of paper that Jason can cut, but it doesn't even get to Shoko to tape together. It doesn't even get to the end. Does that make sense? So even though y equals to x for my whole factory, that's a really dumb factory, by the way. But if I plug in a metal sheet, I don't get a metal sheet because it breaks f of x. So if I put in a 0, so h of x is really this. You actually have to plug in a 0 here, which breaks that undefined. You don't actually plug it in here. This is a simplified version. This is why in this example it's crucial that you write h of x equal to x when x doesn't equal to 0. Because by writing this, you're actually summarizing the entire thing without writing this mess. You see that? Now this is completely identical to that by giving them this warning. Okay? That's exactly why you list a domain. Perfect example. Okay? Thumb up. Are we good now? Okay. I mean, you'll have more opportunity and the quiz for your homework too to kind of make sure you get it. But this is the third time I'm saying something. But this is easier than the gospel. Gospel is 7 times. This is 3 times. Okay. Any other questions on the homework? Let's see. That was number 3. We have 15.
It's okay now.
Is okay now?
Yeah, after you explain number 3, the last one.
Yeah. Oh, perfect example, right? So you multiply it out, the square disappear. You have 25x. but your domain is still greater than or equal to 0. Okay? Okay, perfect. That's the answer they give you for 815. Yeah, all non-negative real numbers. Okay, number 17. Okay, number 17, g of x over f of x. So we want g of x over f of x. This is our new function. This is equal to 5x to the 1/2, 4x to the 2/3. I guess they want you to do x to the 1/3 here, x to the 1/3 here. This will give you 4x, 5, x to the 2 plus 3, 5 over 6. Is that what they want? So what's in the answer key?
Which one is it?
Oh, they have it on the bottom. Sure, that's fine too. So this is equal to 5 over 4, x to the 1 minus 5 over 6, 5, 4, x to the 1, 6. This is fine. This is also fine, I guess. But we'll look at this one. Okay. So just by looking at the simplified version of h of x, I should say that. So h of x isn't actually equal to that. That's actually a simplified version of h of x. Even just looking at that, the domain has to be what? Non-negative because of the 6, and also not 0 because of the domain. So in this case, x had to be greater than equal, oh, not equal to, just greater than 0. And you always have to kind of backtrack and check. So you kind of want to look at right when you plug in g and f and make sure they're okay. Okay, let me give you a scenario that actually depends more on the h than the f and g. Okay, let me give you an example here. Let's say we have h is 1 over x, which means the domain is what? Non-zeros, right? And have g of x, that's x plus minus 2. I want my h of x to be h, oh, sorry, this should be f, sorry, to be f of g of x. So in this case, I'm actually doing 1 over, that's x minus 2. Does that make sense? Okay. So in this case, my domain, oh, that's it, I can simplify more. My domain is x cannot equal to 2. This domain doesn't apply to either of these, right? It only applies to h. Because if you think about this composite function, it's what come out of g that we throw into h. And h can take 0. So we have to avoid g giving it 0. We have to avoid g being given a positive 2. This is why this is what you end up with. So you kind of have to think through. Sometimes it depends only on the h. Sometimes it depends on the f and g. Basically, the moment you write it down without simplifying is that moment you want to check.
So x can equal 0.
What?
So x can equal 0.
No, x can equal to positive 2.
I mean, so can x can
Yeah, because if you plug in 0, 0 minus 2 is negative 2. 1 over negative 2 gives you negative half. And that's just fine. Because f, the function that actually has a problem with 0, won't get a 0 when you plug in 0 to h.
So if it's g of f of x, x can equal 0.
right. Right? If it's g of f of x, then the moment when you actually put product into the factory, what you have is 1 over x minus 2. It cannot be 0 because this breaks your machine. Okay? I know it's a little bit hard, but it makes sense. Once you realize the moment where you have to check, it makes more sense. Okay? And this is why I keep talking about factories. I want you to separate F and G as separate kind of entities, separate buildings. And if you break one or the other, it matters. And in this case, it's the output of G that you put into the factory of F. So what matters is actually the composite of the two instead of what G and H you take on their own. Okay? Okay. There's one more, right? That was 17. We're good. Any other questions on your homework before we move on?